And welcome to part 3. Alright, so here we go. Let's just start off and see where we go from here. So this example, we're going to have a particle moving along the x-axis with a velocity of negative 10 centimeters. Okay, so let's go ahead and graph that out real fast. So I'm going to go ahead and graph this out. And actually, I'm going to have this, right? This is velocity. And here I am. It's got a velocity of a negative 10 centimeters per second. So that means here's my time measured in seconds and constant, so it's just going to be just like that. And so now it says find the change in position during the first 5 seconds. Alright, so the change in position in the first 5 seconds. So here I am at 5 seconds. You guys have done enough of these now to where I'm going to be finding the area that's underneath here. Okay, so, change in position. So you have to remember again, what does velocity, positive and negative mean for us? And you got to remember that a positive velocity means that I am moving either up or right. Depends on what the problem tells us. And a negative velocity means that the particle is moving down or to the left. Again, depending on what the problem tells us. The problem doesn't really tell us anything in this one. So when I talk about a change in position, you pick one of those of what it's doing, of what it's going to be doing. So here I am at negative 10 velocity, so I'm going to choose left. I always like left and right better than up and down. Okay? So we know he's moving to the left. How far to the left? We find the area by negative 10 times 5. And it's not a negative 50 meters, okay, or centimeters. It's going to be they moved 50 centimeters to the left. If you're in physics class, this idea of change in position, okay, can also be done as this is displacement. Okay. Part B, find the position of the particle at t equals 5 if its initial position was 0. Okay, so now that it's telling me that, hey, what is its initial, it gives me an initial position. Now it's telling me, hey, when the time is 0, my particle is right here at 0. Now I'm moving 50 centimeters to the left. So I am now moving this way 50 centimeters. Because I'm now on a number line, that means my position is now at negative 50. So now I have x is equal to a negative 50. So that makes sense. So how else can this see it in part C? It changes up a little bit. It says find the position the particle begins at x equals 6. Well, now this time, I have my position graph. Here I am. Instead of starting here at 0, now I'm starting over here at 6. And I know I moved 50 centimeters to the left. So I still move the same 50 centimeters to the left. Where am I going to end up now? So this is where we come up with what a very important idea, and that is that my final position is equal to my initial position plus my final position plus my displacement. Okay. So in this case, my final position is what I'm looking for. My initial position was 6. My displacement, okay, even though now I'm saying is 50 centimeters to the left, okay, I want to be able to write that as, well, that's represented as a negative 50. So my final position here is going to be at x equals 44. Negative 44. Which will be over here. Okay. So then when I go ahead, hopefully we're okay with this. It seems fairly straightforward. So let's go ahead and take a look at the next problem. My next problem says, hey, now we're going to change it up a little bit. I'm still going to have it moving at negative 10 centimeters. Okay. Let's go ahead and make that red. And then I'm going to have, for the first 3 seconds, and then after that, it's going to move at 3 centimeters per second. Okay, so there's my graph of that. Now it wants me to answer the same questions from A through C above. So again, so here I am, I want to go to 5. I want to find out how to treat that area and how to treat this area. Okay. So again, I want to find the area of both of my rectangles and to be able to find out. So for the first one, it's asking what is my change in position. So with the change in position, I'm going to find out, well, how much did it move to the left? Okay, so from looking here, I'm able to say here it moved 3 times 10 or 30 centimeters to the left. And then it moved 2 times 3 or 6 centimeters to the right. So how much did it totally move? So it went 30 centimeters to the right, the left, 6 centimeters back to the right. So its total change in position was at 24 centimeters to the left. So for part B, it asks, well, if I start at 0, what's going to happen? So again, part B says, if I start at 0, what's my new position? So again, my final position is equal to my initial position plus my displacement. My position, okay, which is then equal to 0 plus, we found out, a negative 24. So my position final is equal to a negative 24. Now you may be thinking, hey, this is really simple, Mr. GL. You could have just drawn the arrow again and just, it's easy enough to put this over here. But I'm putting these steps out very important because not everything's going to be this easy. All right? You need to be able to lay this, to be able to lay this out. Okay? And I'm trying to get this to where there's a formula or a process for you. Okay? Following the same process, for part C, they're asking you again, if my position was at 6, my initial position was at 6. So in other words, now my initial position is at 6. What is now my final position? Okay, again, your final position is going to be equal to 6 plus a negative 24. So in this particular case, it's going to be equal to a negative 18. Okay. Whew. Hopefully that helps out. Hopefully this helps out with your homework, because that's what you have now is your homework. And so you have to deal with 17 through 26 and 5.1, 31 through 36. Again, as a reminder, that's on the worksheet, and this is in your book. All right. Hope you enjoyed. We'll see you next time. Don't forget the quiz. This is all due with the quiz
Bye.